Hello, St. Anthony High School, summer 2023. This is the review for the algebra final. So I will be going over all of the answers in order. This is 6 pages, so it will take a while. All right, so our first set of problems that we're going over is order of operations. So if you remember our order of operations, it is PEMDAS, or parentheses, exponents, multiplication, division, addition, and subtraction. So we need to perform our equations, solve these problems in that order. So the first one, we're going to look for parentheses. I do have parentheses here, so I'm going to start with that. Inside that, I'm going to work through this list as well. So I have an exponent, so that becomes 8 times 5 minus 7. I'm going to keep the parentheses because I'm not done working with it. Divided by 3 plus 4. Next, I'm going to continue to work through that parentheses. I have 8 times 5, which is 40, minus 7, divided by 3 plus 4. Again, I'm going to continue inside that parentheses. 40 minus 7 is 33. I can get rid of that parentheses now because I'm done using it. I've done everything inside that I can. Divided by 3 plus 4. Now I'm going to continue on with my list. The next one is multiplication and division. Here I have division. 33 divided by 3 is 11, plus 4. My answer is 15. All right, we're going to continue on. Sorry, I'm trying to hold my iPad and record at the same time, so I do apologize for all of the movement. All right, so we are going to continue on with B. I'm going to do the same thing. I'm going to work through those steps to perform each one. Again, I have parentheses, so I'm going to need to complete those. So I have 6 minus, I can't do anything with that 8 yet, plus 3 to the third is 27, or 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, plus 5. 6 minus 8 plus 27 is 35, plus 5. Working left to right, I have 6 minus 35, which is a negative 29, plus 5 equals a negative 24. All right, and then we're just going to continue on. So I have 3 minus, I have a 2 cubed, or 8. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 8 divided by 4, plus 5 times 1. Continuing in that parentheses, I'm going to do that division. 3 minus 8 divided by 4 is 2, plus 5 times 1. I have multiplication in what's left over, so I'm going to start with that. 3 minus 2 plus 5 times 1 is 5. Now I'm going to continue on. 3 minus 2 is 1, plus 5. 1 plus 5 is 6. Our answer then is 6. Okay, 3 down, 2 to go. All right, so again, I'm going to work with those steps. I have parentheses again. So I'm going to 7 plus, I have an exponent, so I need to work with that. 4 to the 0 is 1, times 3 minus 2. So I just got rid of that exponent and simplified that. 7 plus 1 is 8, times 3 minus 2. I have multiplication, so I'm going to do that. 8 times 3 is 24. Minus 2 is 22. So we're just going through one at a time each of these steps. Inside the parentheses, outside the parentheses, wherever we have those operations. Okay, now again, I'm going to work with my steps. I'm not going to do this parentheses or this exponent just yet because I have parentheses. 8 divided by 8 is 1, divided by 6 squared. 2 cubed, again, I'm not done in here. This becomes 1/6. 1 divided by 6 is 1/6 squared. The exponent is connected to this parentheses, so I'm going to do that first. So I have 2 cubed divided by, this becomes 1/36. Now I'm going to do my exponent here because I've done everything with that parentheses. 2 to the third is 8. We had that up above. Divided by 1/36. Now the rules are I cannot divide fractions, so I actually have to multiply by the reciprocal. So I'm going to multiply by 36, and this ends up being, I believe it's 288. And you can check the math on that, because to be honest, I don't remember. Let me see if I have my phone nearby. Yes, I do. Alright, get that calculator out. Alright, so we are doing 36 times 8, 288. There we go. Okay, so that is my answer for that one. Alright, down here then, we're working with prime factorization. So what we're trying to do is we're trying to break it down into the basic prime numbers. So our prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and the list just continues on forever. So here I have 12, 24, and 72. You can break these down however you want. If you notice, all of these are even, so a good place to start would be with 2. I prefer to do larger numbers because they break down more quickly, but you can do them however you want. So for this 12, I'm going to break it down into its factors of 3 times 4. Remember, you're multiplying this, you're not adding. So I have 3 times 4. 3 is on my list over here as a prime number. That one, I'm going to stop. My 4, however, is not on this list, so I need to break it down further. This breaks down to 2 times 2. Those are both prime. I don't have to go any further. So this becomes 2 times 2 times 3, or 2 squared times 3. That one is done. Now I'm going to move over here and do the same thing. And again, this one's even. You can break it down however you want. I'm going to do larger numbers. I'm going to do 4 times 6. 4 is not on this list. We did have it over here. We're going to do that same thing again. I have 2 times 2. My 2's are prime, so I'm done with that. The 6 is not on my list either, so I'm going to go ahead and break that one down. So that becomes a 2 times 3. Again, remember, you are multiplying. Okay, it needs to be multiplied. So I'm going to write those out in the same manner. So I have 2 times 2 times 2 times 3, or 2 cubed, because I have 1, 2, 3 2's, times 3. All right, last one then. I have 72. We can divide this by 2 if that's easier for you, if it makes more sense. I'm going to do 8 and 9. 8 times 9 is 72. So again, this just breaks it down a little bit faster. 9 then is 3 times 3. 8 is 4 times 2, and I did that on purpose so that I wouldn't run into the 3's. 4 is 2 times 2. So here I have 1, 2, 3 2's, 1, 2, 3 2's, and 2 3's. That should be 2. Or 2 cubed times 3 squared. Now, one thing I noticed previously is that you weren't writing what all three numbers have in common. Okay, you need to indicate what number all three have in common. So if I look back here, they all have 2's, they all have 3's. Now what I need to figure out is how many they have in common. Here I have 2 2's, I have 3 2's, and I have 3 2's. Well, the most they have in common is 2, so it's going to be 2 squared. Now I'm going to look at those 3's. Here I have 1, 1, and 2. Well, the highest they have in common is 1. So that is the answer. You must have all of these answers in order to get your answer completely right. I need to see the factor tree or the division, if you remember the division. Either one of these for all three values, and then what they have in common. That needs to be included in all of your work in order to get full credit for a problem like this. All right, let's move on to the next page. Problem 3 here is fairly simple. It's asking for the slope and y-intercept. Your problem here is in slope-intercept form, which means that all you have to do is copy down those values. So I'm going to write slope and y-intercept. The slope is the value that's next to the x. That is 2. The y-intercept is the value that's hanging out by itself. In this case, that's 1. The next question is asking then, graph the above equation using the coordinate plane. So we're using this equation and putting it on here. The best way to start this, well, actually there's two ways. One way is to use the intercept and plot that, and then use the slope to move around, or you can make a t-chart. In this case, I'm going to do a -1, 0, and 1. Then you replace these values one at a time. You're not doing them at the same time. You're taking them one at a time and replacing them into this equation. So what you're going to do is you're going to do 2 times your first x value, which in this case is -1, plus 1 equals. 2 times -1 is a -2, plus 1 is a -1. My first point, because this is equal to -1, this is that y value, that goes in this y value chart. I'm going to do the same thing with that 0. 2 times 0 plus 1 equals my y. 2 times 0 is 0, plus 1 equals my y still. 1 equals y. So the next point then, that 0 corresponds to a 1. That's the next point that I'm going to have on this graph. Then the last one I'm going to do is 2 times 1 plus 1 equals y. 2 times 1 is 2, plus 1 still equal to my y. 2 plus 1 is 3. That last point then is 3. You must label all of your graphs. So here the center is my origin. That's labeled with a 0. This graph is fairly small, so you might have trouble putting those points on here. So you can count them in 2's, 5's. I'm going to do 2 for this side, 6, 8. This side, it's a little bit more difficult because we have negatives, so it might be easier to put a negative or go by 5's. 1, 2, 3, 4, 5. -5, 6, 7, 8, 9, 10. And again, it doesn't matter as long as you label. If you wanted to try and do all 3, 4, 5, 6. If you wanted to try and do all of it, you can. If you notice that's a little scrunched, so it's easier to separate it out a little bit. -2, -4, -6. All right. So now I'm going to come back in with my pencil, and I'm going to plot those points from our T-chart. So the first point that I'm looking for is -1, -1. So -1, this means I'm going left. So I'm going left 1, and then -1, down 1. The next point is 0. I'm not moving left or right. I'm just going to go up and down. That one is at 0, 1. And then my last point is at 1, 1, 2, wait, 1, 2, 3. There it is. And you should notice that it makes a line. Then you're going to connect those and put an arrow on each end, indicating that it's continuing on forever and ever. All right, problem number 5. How many do I have total? 13. All right. It says, the manager of a furniture company finds that it costs $2,700 to manufacture 150 chairs in one day and $5,400 to produce 300 chairs in one day. So we know that it costs $2,700 for 150 chairs, and that's dollars. And then it also costs $5,400 for 300 chairs. So I need to figure out essentially how much it costs per chair to be produced. So I can make these into equations based on the information. So this first one here, my total cost is going to be $2,700, and that's equal to the number of chairs total for the cost. And then I can also do the same thing with that other value. So I'm going to have 5,400 is equal to 300 chairs times that cost. To figure out what that C is, I need to divide both sides by those values. So here I have 150. I'm multiplying that times the cost to get the total cost. So I'm going to divide both sides by 150. And that is equal to, let me get my calculator again. All right, so I have 2,700. Divided by 150. That gives me 18. So it costs $18 per chair to make it if I'm making 150 chairs. Okay, we're going to just see if we get the same value with that 540. Again, I'm multiplying the 300 times that C, so I'm going to divide both sides by 300. So let's see what we get. Here I'm going to do 5,400 divided by 300, which again gives me 18. So no matter how many chairs I make that day, it's going to cost me $18 per chair to make those. So now, to make our equation, express the cost as a function of the number of chairs produced, assuming that is linear, then sketch the graph. So it's telling us to write a function. So we have f of c, the function of the cost, is equal to $18 times each chair. So what this is saying is that the total cost, actually nope, that works. The cost of the chairs that I'm producing each day is based on $18 per chair. So if I make 12 chairs, 150 chairs, 300 chairs, 1,000 chairs, it's going to cost me $18 each time I make that chair. Okay, now we're going to create a graph based on that information. If you notice, the graph has increments of 50. So I'm going to make my T-chart with these values to help me properly put this graph in place. So I'm going to make my T-chart. If you remember, our equation is f of c, or y, equals 18c. The values I have on the bottom are 50, 100, 150, 200, and so on. You can do as many as you want. You need to do a minimum of 3, as 3 points determine a line. So I'm going to pull out my handy dandy calculator again. Biscuits, there we go. Okay, so the first value I'm doing is 50. So I'm going to do 50 times 18. That gives me a value of 900. So I'm going to write 900 on my chart. Okay, let's do the same thing. I have 100 times 18, 1,800. We have 150, but we'll try it again. 2,700. And then we'll do 200. 3,600. These values on the side are in thousands, so you have to estimate a little bit when you're putting these on the graph, but you can still make it work. So here, the first value I have, the first point is going to be 50 and 900. I'm going to go over to this 50, and then I'm going to go up almost halfway is where that 900 is. And again, I'm estimating because I can't completely see that where that should be. The next one is going to be 100 and 180. I'm going to go almost to that top dotted line where that 2 is, estimating that 1,800. The next one I'm going to go over to is 150. The matching value for that is 2,700. So again, I'm going to go up about a third of the way up. And if you notice, they're starting to, it's not a very nice line, but they're starting to create a line. And then the last one is 200, 3,600. So I'm going to go 200, and then about 3/4 of the way up. Then these are going to get connected as well. Hold on. Can't look at this screen and do this at the same time. Okay, so that would be the line, the graph for that. All right, so here we're going to look at this in the sense that it's slope-intercept form. I'm going to add a 0 to complete that slope-intercept form because I need to be able to properly identify the pieces. The reason I'm adding 0 is because if I don't make any chairs that day, I'm not spending any money. I'm not paying anything to make those chairs. So if you remember, the slope is next to your variable. In this case, our variable, I used C to represent the chairs. You could have done anything. So our slope here is 18. And then it says, what does that represent? So the 18 represents the cost per chair, or you can say the cost to make each chair, something like that. Then we want to know, what is the y-intercept? Their y-intercept is 0 because, again, it doesn't matter how many chairs we're making. If we don't make any chairs, it's not going to cost us a penny. Maybe it's Saturday, no machines are running, nobody's working, we're not making any chairs, so we're not spending any money. Okay, so it says, what is the y-intercept? We've identified that. And what does it represent? Okay, so this represents the cost if no chairs are being made. Okay, here, number 6, we're identifying the sequence. So the sequence is 1, 5, 25, 125. So we're trying to figure out how we're going from one number to the next. Most of the time, you guys are trying to add. When they're going up this quickly, they're going to be multiplied. So how do I go from 1 to 5? Well, I'm going to multiply 1 times 5 to get me 5. Then I'm going to check to see if that value is going to continue on. 5 times 5 is indeed 25. 5 times 125, or sorry, 5 times 25 is 125. So now I'm going to grab my calculator one more time. So I am multiplying times 5 each time. But the question is asking for the next 3 numbers in this sequence. So I'm going to take 125, multiply times 5, that's 625. So the first value is 625. Then I'm going to multiply times 5 again. So that gives me a value of 3,125. And then I'm going to multiply that one more time because I'm asking for 3 values. So that ends up being 15,625. So now I have 1, 2, 3 values in that sequence, continuing on. So 7 then asking, is there a common ratio for the above sequence? If yes, what is it? So to find the common ratio, we have R equals A2 divided by A1. Our A2 just means that we're taking the second number in a pair of numbers. So we can take this 15,625, 3,125, 625, 125, 25, or 5. You cannot take this first number yet because I need the second number. So whatever pair of values that you're choosing, you have to take the second one. So let's do a number that we've calculated and a number that's already there. So I'm going to, isn't he cute? I'm going to do, come on, there we go. 625 divided by 5. Nope, sorry. 625 divided by 125 is 5. And I can do that with any of these pairs of numbers. So I can come back here and I can do 125 divided by 25 because I know I didn't actually calculate those. 125 divided by 25 is 5. So I'm still getting 5 no matter which pair of numbers I choose. And again, you can choose any of those numbers to do that common ratio, which is this formula. And these are my answers, which also matches that value that I've calculated up there. All right, let's continue on. All right, so question 8. Yep, okay. Identify which of the following are a function. Oh, excuse me. Okay, so in order to make sure that we have a function, it's typically a 1-to-1 ratio. And the ratio starts with that x value or that input. So we're looking from the left to see which one of those are by itself. So here I'm going to look at the top. I have 6, 8, 11, and 14. I have individual lines coming out of each of those. So yes, this one is indeed a function. In the second one here, I have a -9 with a 4, a 2 with an 8, a 0 with a 1, a 6 with a 5, and a 2 with a 3. Because I have a 2 here and a 2 here as my x, those are the same x values, which I cannot have. So this one then is a no. All right, let's move on to that third image. Again, I have values coming out of each of those x's. I do have 2 lines going to that too, but that doesn't matter. That could mean that I have a parabola or an absolute value where I have the same number on both sides. But since I only have one of these, this is a function. All right, and then let's look at this last one. I have a -9 with a 4, a -8 with a 3, a -8 with a 1, a -6 with a 0, a -4 with a 3. Again, I have 2 x values that are the same trying to go to 2 separate points. That cannot happen, so this is a no. All right, question number 9. So it says complete the chart with the degrees of the polynomial functions, the corresponding type, and an example of each. So the degrees then are the floating numbers. It's those exponents. So if you recall, I compared it to, let's see, it is 78 degrees outside currently. This degree symbol is the same as my algebra degree symbol. It's that floating piece to tell me what that degree is. So the degrees that we discussed are 0, 1, 2, 3, 4, and 5. The type of a degree 0 is a constant. And the reason why is because anything to the 0 power is 1. So it's just a constant value that you would be multiplying by. 1 then is going to be linear because I just have one piece there. 2 is quadratic. 3 is cubic. 4 is quartic. Think of like a quarter. Quartic. And I was writing quarter. And then 5 is quintic. Okay, so you can kind of remember that by like quince. Quince is 15, or 1 and 5. 5 quintic, quince. You have connections there. Here for the examples, you can either do x's all the way down, or maybe you want to do numbers. Okay, anything works as long as you have a base value and then your number. Okay, so either of these or a combination of these would be valid. I'm just making up random numbers as my base, but make sure that your degree here matches your degree in the first column. They have to be connected. Or you can even do a complete equation. So I can have x to the 5th plus 4x to the 4th minus 6x cubed plus 8x squared minus 7x plus 6. This one, that reminds me, this one can either be written with just the x to the first or the x, and it also can be written as that. Because that 1 is technically invisible, it does not necessarily have to be there. But any of these would be sufficient for your answer. All right. Almost done, guys. All right, let's come up here to solving the equations. So what we're doing here is we're trying to get those variables by itself and figuring out what they equal without all the rest of that stuff around. So for this first one, because those numbers and variables are in those parentheses, I have to distribute the numbers that are outside those parentheses to get at them and be able to solve. So I have 2 times 4 minus 1. I'm multiplying this 2 times everything that's inside. So I'm going to go 2 times 4, which gives me an 8. 2 times I, which is a 2i, minus, and again I'm going to do the same thing, 3 times I. 3 times 3 is 9, equals a negative 9. So now I'm going to start to combine like terms. You can only combine things that are the same. So this is a great example. I have 2 values that have variables, and I have 2 values that don't. So the values that have variables, I can combine those and put those into one piece. The ones that don't, I can combine those and put in those into one piece. So I will start with the ones that don't. 8 plus 9 is 17. Yep. And then a negative 2 minus a 3 is a minus 5i, equals a negative 9. Now that I've written that so that there's one piece for each item, I can start to solve it. So I have 17 minus 5i equals a negative 9. I'm going to subtract. I feel like I made a mistake. 8, 2, 3. Oh, this should be a negative 9. See, even I make mistakes. Okay, so that then becomes 8 minus 9 is a negative 1. Sorry, friends. See, even I make mistakes. Okay, let me just make sure I'm doing this right. 8 plus 2i minus 3 minus 9 equals negative 9. 8 minus 9 is a negative 1. Yes, all right. So now I'm going to come over here and I'm going to add 1 to both sides. So I have 1, a negative 1 plus 1 gives me a 0. I still have this negative 5i. A negative 9 plus 1 is a negative 8. Now I need to get this I all by itself. So I'm going to divide both sides by a negative 5 since I'm multiplying. I equals a negative 8 divided by a negative 5 is 8 fifths. Those negatives go away since I'm dividing both. Sorry, friends, I'm tired. Okay, let's go ahead with B. So I'm going to do the same thing, although this time I have my parentheses on both sides. So I'm going to multiply, distribute them separately, and then I'm going to start to compare them. So I'm going to substitute this distribute the 2 into everything in the parentheses. 2 times k is a 2k. 2 times 10 is 20. 4 times k is 4k. 4 times a negative 5 is a negative 60. Now I have a parenthesis and a number on each side. I'm going to move all of the variables on one side and all of the values on one side. So since that 2 is smaller than that 4, I'm going to move the 2 over. First, I'm going to subtract it from both sides. So I have 20 equals 4 minus 2 is 2k minus 60. Now the good part about this is that 60 is negative. So I'm getting rid of that negative as I'm doing this. So I have, so I have 20 equals 2k minus 60. I'm going to add 60 to both sides. So what I'm left with is 80 equals 2k. Divide both sides by 2 since I'm multiplying here. 40 equals k. All right. Last one. So here I have that same situation essentially, but I don't have any parentheses. So I'm going to subtract the r since it's smaller. So I have 3 minus 1 because there's an invisible 1 there. 3 minus 1 is 2. 2r plus 2 equals a negative 6. I'm going to subtract the 2 because I want all of the numbers to be on the other side. So I have 2r equals a negative 8. I'm multiplying this 2, so I need to divide it. So r equals a negative 4. All right, now we're solving again. However, the difference this time is that I have absolute value symbols. Those lines, that means I have an absolute value. If I have an absolute value, whatever is inside those absolute value symbols, those lines, is automatically positive.